Okay, let's start question number 3 of October number 25, paper 4-2. Okay, what are they saying in question number 3? So question number 3 is a binary tree question, which has been tested after a while. So a program stores integers in ascending order in an ordered binary tree. The tree is implemented as a 2D array. Okay, so we know that in a binary tree, we always get three properties of every node. So there is going to be a node which will have a left pointer, the data, and the right pointer. And then all the values will be stored in an orderly manner. So all the null values will be stored as -1. The binary tree can store up to 50 nodes. Okay. Nodes cannot be deleted from the binary tree. All right. A binary tree is stored as a global array with the identifier tree array. So tree array is equal to this. Then the left pointer and right pointer to each node are initialized to -1. The global array variable root pointer stores the index, which is initialized to -1. Okay, let's set it to, so root pointer will be set to -1. And then they're saying the global variable free node will store the index of the next free node, which will be initialized to 0. So free node is set to 0. Okay, then write the program code to declare the and initialize these three arrays. Okay, so we have the tree array.
The right pointer को
So we have to declare and initialize all of these. Okay, so root pointer is done, free node is done, we have to initialize tree array. Okay, the maximum size is 50. So again, what we can do is we can simply do it in one line, because they are saying that we are using a 2D array, so it will have the pointer to the left, then data to the right. So I'll say the array like this. We have -1, comma -1, comma -1. So for I in range 50. And if I simply print this, so this will print me a tree array which will have 50 nodes that will be set to -1. So if I run it, so it will have 3. And if you don't want to, if 50 is too lengthy, so maybe you can just change it to 5 and just quickly check. So 0, 1, 2, 3, 4, yeah, 5 values, all separated into their own arrays. Okay, we'll change it back to 50. Then in the next part, they are saying that we have to create a function for adding a node. Yes, in part B, they're saying now we have to add a node into the binary tree. Okay, so takes an integer as to store in a binary tree as a parameter, stores the parameter in the next tree node in the array, finds the position to store the data in the tree by following the appropriate pointers, updates the pointers of the new node's parent node, and the procedure outputs the tree is full if the parameter cannot be stored because the tree is full. Okay, so before we do this, let's quickly go back and see how the binary tree works. Okay, so a recap of how binary trees work. So we have this website here. So what I'll do is I'll just put in some random values. Maybe we have 50. So first of all, 50 goes here. Then if I want to add 40, so 40 is less than 50, so it goes to the left of 50 like this. So we will now update the left pointer of 50 to point to this value 40, and 40's left pointer and right pointer are set to -1 because there is no value after this. I have value 90. Now 90 is greater than 50, so it goes to the right of 50, and now 50's left and right pointers both have been updated. Now the next time I want to import maybe 45. Since 45 is less than 50 but greater than 40, so it goes to the right of 40 like this. So if we find the left node or the right node to be -1, we will add the node there. But if we find that the value is not -1, then we will follow the node. Okay. So let's say now we have a value of 40 here. Maybe next value I input is 30. So 30 is less than 50, 30 is less than 40, so it goes there. Now, if the next value I'm going to add would be maybe 2. So we'll check the left pointer of 50. Is it equal to -1? No. So we go to the left, that is 40. So we check, is the left value to the 40? Yes. So we are going to set it, we're going to go to 30, and then we're going to check, is there a value to the left of 30? No. So we're going to place the value of 2 there. And we keep on repeating this over and over again. And this would all be done in a 2D array. So just a quick reminder, how does that work in a 2D array? So let's say we have this example of binary tree here, and this is how our code would look like. So we have some values. So it will have a free node. Maybe free node is pointing here right now. And we have only one node, that is 20. So the left and right would be set to -1 like this. So -1, -1, -1, -1. So these would all be -1s. Okay, now the next value I'm going to input could be 50. So we know 50 is greater than 20. So what I'm going to do is, first of all, I'm just going to place the value 50 into my binary tree, and then I will also keep a track from where we started. So this would be the start or the head node of my linked list. So in the question, I think they called it something else. It was called the root pointer. Yes. So we'll also call it the root pointer. So this is the root pointer. So root pointer is pointing to 20. So I'll remember from which node I iterated previously, traversed previously. Then when I go to 50, I should remember where we came from. So we came from index number 0, where 20 was stored. And since 50 is greater than 20, so what I'm going to do is I'm going to update the right pointer of 20 to point to 50, and 50 is stored at index 1. So this would become 1. So how would it look like? Again, if I redraw, so I'll have 20 here. And then if I insert 50, so 50 goes to the right side of 20. Okay, and then free node should now point to the next available node, which is 2. Okay, now the next value that I'll input would be 10. So 10 will go to the left of 20. So what I'll do again is I'll input 10 in the array, wherever the next free node is. And then I need to remember, I'll need to start from the first node. So I go to 20, and from 20, I see the left, I see the right. So the right value is 1. So um, I have to input 10. Okay, so 10 is less than 20. So I know that we have to go to the left of 20. Since it is equal to -1, that means we have to just put the value there. Okay, so what I'll do is now I have to point the left of 20 to the index where 10 is stored. 10 is stored at 2. So I'm going to update this and point it to 2. And then 10 will become part of the binary. So we just have to always remember the parent of the new node where we attached it, so we can track back and update the pointers accordingly. Okay, with this recap, we will go back now and we will try to implement the solution or not. So, okay, let's start the module. The procedure is called add node. Let's get into this. So define add node, and we'll add some new node here. Let's call it new node. And then we are going to global all of the variables, global root pointer and global tree array. Okay, first of all, they're saying you have to check if the tree is not filled. So the size of the tree is 50. So we will check if free node is the node that is pointing to the next available space. So if the free node becomes greater than 49, so we'll print that the tree is full like this. Else if that is not the case. Okay. So when that is not the case, we are taking an integer as a parameter. Okay. Then we are storing the parameter in the next free node in the space. Okay. So now free node is always going to point to the next available space. So the same array that we had here. So we have the left, then we have the data, then we have the right like this. And this is all set to -1, -1, and -1 initially. And maybe here we have the, so this would be initially the head node as well, or this would just be the free node right now, because there is no value in the binary tree. So what I'm going to do is I will simply put the values. So I'll say tree array, the value at the free node column 0. So this is the column 0, this is column 1, this is column 2. So column 0 will put -1 because this is a new node. Then tree array, free node, column 1, this will get the value of the new node. And then tree array, column 2 will get -1 as well. Right? So it will look literally like this. And then this data would have a value. Now let's say I inputted 50 here. So this should now become 50 like this. Everything else remains the same. Okay.
सही है समझ
So once we have done that, Then we should also check if the root pointer, that they've said that the root pointer is equal to -1. Now, if the root pointer is equal to -1, that means this binary tree was empty. So if the binary tree was empty, then this should become the head node as well, right? This should become the root pointer as well. So root pointer should now point to this index 0 root. This should also become root pointer, and I'll add the indices here. Let's indent this, and let's add, this is index 0, and then down here we'll have index 1, then we'll have index 2, then we'll have index 3, like this. So this would also become the root pointer. So that is what I'm going to do here. I'm going to check if the root pointer was initially equal to -1, then now since we have added a value, so now the root pointer should become equal to 0. So now it will point to this free node that was, well, it was previously free, but now we have placed a node there, so it's not going to be free anymore, and we are going to update the pointers. Okay, what next? So
तो
if
ये
that
pointer बता देंगे।
else, so what will happen is now we have to find the spot in the tree. So let's say if that is not the case, maybe there are multiple values here. So 50. So we maybe have 20 here. So it will be on the left. So this would be, this left pointer would be 1. And maybe I'll input a value 100. So that would be go on index 2. So we'll have 100 here. And let's make these -1. And this could also be -1. This, and same on the other side.
नहीं सर, वैसे 20 के राइट में तो 15।
Okay, so this is how the 2D array would look like with some values in it, 50, 20, and on the first we have 50. On the left we have 20. So on the left we have this 20, and on the right we have this 2, and at 2 we have 100. Okay, now how do we find this point? So what we have to do is now we have to start from head node, and then we check if the new item is greater than the value at the current node. If it is, then we have to go right. Else if new item is less than the current value, then we have to go left. And once we have done that, then we are simply going to once we have found the right point, then we're going to insert the node. Okay, this, and secondly we also have to in this case, yes, so we go to the right, and we also need to check if the value is set to -1. So if the new item is greater than the current value, then we should first check if there is a right node. If right node is equal to -1. So if right is equal to -1, then we will place it here. Otherwise, else will go right like this. Okay, again, so in this case, if the left point is equal to -1, then we'll place the node here directly. Otherwise, we will end up going to the left. So just like we saw in the diagram before. So again, if I want to add maybe 70 now, so 70 is larger than 50, so it will go to the right. But on the right, 100 is already there. So now we cannot put 70 in place of 100. We need to go to the right of 100 and then add 70 there, to the left of 100. So this is how it's going to be. And I will just comment this. I'll just cut it and paste it below. So we can just see the code as we write. Okay, first of all, we'll create a variable. Let's call it placed, or let's call it found, or let's call it inserted, whatever you want to call it. Okay? So inserted is equal to initially false. This is again just a Boolean variable. Then we are going to start our current node from the root pointer. So we are going to set it to root pointer. Again, what is root pointer storing? It is storing this 0 or this row number. Okay, it's not storing the value 50, 20, or 100. It's just storing the index at where the value is stored. So we start from the root pointer, and then we are going to check while inserted is false, while not inserted. As long as that is not the case, now we have to check. So we check if the new item is greater than the current value. So again, current is storing the index. So the data will be stored at column number 1. Column 0 is left, column 1 is data, column 1 is right. And that's what we have to do. So we'll check if the new node is greater than the value at the pre-array current rows data value, which is column 1, right? So we are checking if the new value that we're adding, again, let's say the value that I'm going to add here now is, so we have 50, 20, 100, maybe it could be 90. So I know that 90 is greater than 50, so we have to go right. So that is what I'm checking here. Okay, if that is the case, now what we'll do is we will then, so like we discussed here, we will first check if the value to the right is set to -1. So that is what I'm going to do. I'm going to check if the pre-array current index, the right pointer value is equal to -1. So let's see. I'm going to input 90. So I start from here. Okay. Since 50, 90 will go to the right of 50. Is the right equal to -1? No. That means I cannot place 90 in this spot. 100 is already there. Okay. So if it is, let's say if it is equal to -1, then what we're going to do is, let's say 100 does not exist here. So what you can do here is you literally just put 90 in this spot and then you update the pointer, right? So that is what we're going to do. We'll say that if that is the case, then create array current index. Next point, the right pointer will now point to free node, and we'll say that the value was, it is called recorded inserted would become equal to 2. Okay, what did we do here? So at this time, when we are inputting 90 here, the free node would be pointing to this index here, right? And this would be -1, and this would also be -1. So free node would be pointing here right now. So when I start from 90, when I pick 90, I start from 50. So since 90 is greater than 50, we have to go right. So we go to 2, and okay, when it is equal to -1. So let's say this 100 does not exist for now. So the free node will be pointing to one row above. Free node is pointing here. So let's say this was also set to -1. And we store 90 initially. Okay. Now we have to update the pointer. So what we have to do here is free node is pointing to 2 right now, which means that our current node's right pointer should also point to free node, right? So this is what I'm doing here. I'm saying the current node's right pointer should now point to free node, because this is literally where we put in the value. Once this is done, once this value points to 2, now I'm going to increment the value of free node, and I'm going to make it point to the next node, which is unfilled right now. We'll input a value once we get a value. Okay, so this would mean that we have put in the value. Okay, what if that is not the case? Else, if the value is not equal to -1. Okay, now let's say if I want to input 100 now. Okay, what will happen now is, since 100 is greater than 50, so we go to the right, and at index 2, again we have another value which is 90. So now what we need to do is we need to go to the right of the current node, and we keep on doing this until we encounter -1, until we find the place to insert the value. So then we'll go to the right of 90, and since this would be -1, then we'll place 100 to the right of to the left of 90. So, right? So that's the idea. Okay, if that is not the case, if the value is not equal to -1, then we are simply going to go right. So how do we go right? We'll just say current is equal to pre-array current and go to the right pointer. Literally, that's it. So what does it mean? So I'm adding 100. 100 is greater than 50. So what do I need to do? Since I cannot add 100 here, so I'll say go to the right of the current node. So current node is stored at index 0. The right pointer is 2. So I will go to there, to that point. Again, I'll check, is this equal to -1? No. So what do I have to do? I need to now go to the right of it. Okay, this right is -1. Okay, this means now what I'll do is I will update this right pointer. But well, since let's make it okay, this is 100 is fine. Since 100 is greater than 90, and since 100 will be stored to the right of 90, so I'm going to say that update this right pointer to the free node value. Free node is pointing to 3 right now. So we will update this to point to 3. And in this way, we will get a perfect tree where we'll start from, we'll have 50. Then the next value that we inserted was 20. So 20 goes on the left, then 90 goes on the right, and then we added 100. So 100 goes on the right of 90 as well, like this. And everything looks good so far. So if you understand it for the right part, and then it's very easy for the left part as well. Okay, once this is done, so inserted is set to true, and okay, then we will do else, and we have to repeat the same thing for if we'll check if the new if new node is less than this, then we check if the current values left pointer is equal to -1. If that is the case, then we are going to assign the free nodes index to the left pointer, and then we are going to say that the value has been inserted. And if that is not the case, if the value is still not equal to -1, which means, let's say I want to insert 10, but I cannot put 10 here because there's already a value here, so I need to go to the left of 20. So for that to happen, I'll just say tree array. I'll just say current should become equal to tree array current index left pointer, which is set. Okay, my bad. This is left pointers are at column 0, not 1. Column 1's data. So this should all be 0. So this should be 0, and this should be 0. I was using automated. Okay.
submit आपने वो
Okay, so with this the value is done. So maybe we can change this elif to be more elaborate. So new node is less than the value at the current node, like this. So this will, if I add a comment for our convenience, this will go to the left subtree. In fact, this will go to the right subtree, and this will take us to the left subtree. So here the values are for the left column, which is column 0, and then here the values are 2, which are for the right pointer column. And then this goes to the right pointer, this goes to the left pointer. Okay, so looks good so far. Okay, when the process is done, when this if condition is complete and this if condition is also complete, then in either case we have to increment the value of free node by 1 because we have inserted the value in both cases. So as long as that is the case, we will keep on doing it. And then yeah, that's it. Okay, so add node is done. Then part C says that the text file tree area stores 50 integers. Okay, so let's bring this file, which is in the source file. Okay, we have the source file here, and there are some integer values in this. Okay, now let's see what the question says. I'll get rid of this extra code. Okay, so the tree can stores 50 integers. Each integer is on a new line in the file. The main program reads each integer from the file and stores each integer in the binary array, in the binary tree in the order they are read. Write the code for the main program. Okay, so we just have to read the file and we have to add the nodes. Okay, not an issue. So this would be the main program, and let's just hide all of this. Okay, so we'll first do try except. Okay, in the try method, we'll open file is equal to open tree data.txt in read mode. Then we'll say for line in F, and we'll say, let's say the current is equal to line dot strip. So we remove the spaces, and once that is done, we will call the add node function, add node the current value, and then we will close the file like this. And if that is there, it doesn't work, so we'll print file processing error or something. Okay, then they're saying the procedure write all to the file stores the content of tree array in a new text file. Okay, and with the file name tree.txt, the txt is not provided. Okay, each node in tree array is stored on one line with a comma separating value. For example, the current contents of tree array are this. After writing tree array to the text file, the tree will contain -121, -130, -1. Okay, so basically they're just asking you to write the contents of 2D array into a file where you'll have the left pointer separated by a comma, data separated by a comma, then a write pointer, and then you also have to use exception handling in this case. So write all to file, again, very simple. So we will write define write all to file. Okay, so we are not going to take any parameter here. We have to use try and except. So print, let's say, file writing error, because we'll be writing to the file. Okay, in this we have to we'll try to open the file. The file is called tree, and we're going to, so they are saying that the content of tree array in a new text file of the file, this tree.txt is not provided. Okay, so maybe we can just open it in write mode in this case, and then we can add the value every time. So, or there is also the A plus mode, which means that you can open it in append, and you can also, if it doesn't exist, then the file will be created for you. So that's the idea, or we can just simply use the write mode. So file open is equal to tree.txt, comma, and we open it in write mode, then we have to close the file eventually. Okay, then we're going to say for how many values do we have in the array? We have 50 values. Okay, so we are going to get them one by one, and we also need the indices because this is a 2D array. So for I in range up to 50, like this. All right, so when I will print one line for I in range 50, it would get me this 1D array, one 1D array at a time. So I cannot just print the whole 1D array. I need to pick the values out. So let's get the values out. Let's say the left is at the tree array current index at 0, right? Again, this, it would get me this 1D array out like this. I will just comment it here. So when I say tree array index 0, it would get me this 1D array. Now from this 1D array, I need the 0th value, which is the left value. So this is what I'm doing. It's a 2D array. So we need two indices. Then I'll get the data out, and then I'll get the write pointer out. So you can do it in one line, but it's just better to do it in two lines, 3 lines with different variables, so there's very little confusion. Okay, so we do this. Now they're saying you just have to write these values in a line by separating them with a comma. So line is equal to, or data is equal to, or content is equal to, let's call it line is equal to. So these values would be in the integer format. Okay, so they are all integer values. So we need to convert them to strings before we write them into the file. So string, okay, let's use the format string. This would be left, data, right, and they would be separated by the columns like this. And let's convert them to string here as well. This becomes a string like this, and then we convert this to string, this to string, and that's it. So the line is done, everything is ready, and now we just have to place this. So I'll say file.write the line, and then we will end up closing the file. And once that is done, they're saying amend the main program to call the write to all. So write all to file. So after we have added all the nodes, and maybe even after we've closed the file, I'll just make a call to write all to file. And then they're saying test your program, take a screenshot to show the contents, and screenshot, make sure the file name is visible. Okay, let's see what will happen. Okay, so this is the output from the tree file. This is all correct. What we did was here, so this function was fine. This tree node, I think we had misindented it inside the value. So this would be outside the value. Okay. Only once the node has been inserted, only then we'll count it as one node. So then we'll increment the value of it by 1. And we also have to add a line break in every line. So it goes to the next line, and then we write it. And then when we print all the contents of the tree file in read mode, so it will print us this. And with this, the question tree is also done.